Tissue engineering and artificial organs. Welcome to our new video. In this video, I will present you some curiosities about the creation of artificial organs. The following aspects will be addressed. What is tissue engineering? How does the process of creating tissues work? Organs successfully replicated in the laboratory, clinical and laboratory examples, and advantages and disadvantages of artificial organs. Get ready to learn amazing things about organ engineering and surprise your friends with these interesting facts. What is tissue engineering? Tissue engineering is the science that is responsible for growing new cells to create tissues in the laboratory. To create these tissues, they mimic the nanostructure of body tissues. This science seeks to use biocompatible materials to avoid negative reactions in the organ. This material must serve as support, protect the cells that are around it, and enable cell regeneration. How does the process of creating fabrics work? For the reconstruction of organs, the use of various materials is investigated, such as artificial or natural ceramics, biodegradable plastics, and matrices of donated or animal-derived organs. In this last example, a decellularization process is executed to avoid immunological reactions. Decellularization consists of extracting the donor's cells and replacing them with those of the person who will receive the transplant. These materials serve as the basis for building the future organ and repeat cell signaling stimuli. This model is also loaded with cells from the patient, which speeds up the regeneration process. If there are not enough cells from the same tissue, stem cells or cells from other tissues are looked for. Previously, a sample of the cells of this organ is collected and these cells are cultured. These cells grown on top of the scaffold are seeded until they cover it. These cells need to be positioned in a specific place and the layers are placed one by one. There is also research that plans to use 3D printers loaded with biocompatible materials to speed up the process of creating this scaffold. The use of the 3D printer can reduce the creation time of the scaffold from 9 hours to a few minutes. Dr. Chijo's impression method was able to reduce this time to 9 minutes, however, it is still not capable of building complete organs. After this initial model preparation process, it is introduced into the bioreactor. This device is responsible for mimicking the functions of the organism to provide physiological conditions as close as possible to the human organism so that tissue development and maturation occur. The functions of the bioreactor are: control the temperature, exchange gases, nutrients, and waste from the cells. The final tissue is implanted in the damaged organ to promote regeneration. Organs successfully replicated in the laboratory. In humans, until then it has been possible to implant flat organs, skin, tubes, blood vessels and urethra, and non-tubular hollow organs, stomach and bladder. Solid organs could not yet be implanted due to the complexity of these organs. One of the biggest problems in creating these organs is connecting the veins, arteries, and capillaries to supply blood and keep the organ alive. Clinical and laboratory examples. Molly Stevens is a UK professor who led research into the application of smart polymer systems for bone culture. This innovative method was able to create large amounts of mature human bone and other organs that are more difficult to replicate, such as the liver and pancreas. The best-known example of an artificial organ is the artificial skin that is generated from a collagen membrane, helping patients with burns or cosmetic surgery. Doris Taylor is a researcher from the United States who managed to decellularize the heart of a rat and inject heart cells. 8 days after the procedure, she stated that the heart was beating. Using the impression, Dr. Atala managed to build a miniature liver capable of metabolizing drugs. Now the next challenge is to make it life-size. An artificial ear was created that after 12 weeks of growth was implanted in a rat. The artificial organ looks similar to the natural ear and also retains its flexibility. This study was conducted by scientists at the Massachusetts General Hospital, Boston, and animal cells were used for this. Advantages and disadvantages of artificial organs. Spain is a reference in organ donations, yet the numbers of people who need a transplant exceed the number of donations. Tissue engineering could help heal this lack of organs. Another advantage that could be provided by lowering the price of artificial organ creation is the decrease in organ trafficking and kidnapping. Although there are already successful cases of artificial transplants in humans, more studies are still needed and the costs for this procedure are still very high. Since these organs are created with cells from the individual who is going to receive them, the risk of transplant rejection tends to decrease. Thanks for watching this video. If you liked it, don't forget to like and subscribe to my channel to receive more content of this type. And tell me in the comments, what is your favorite organ?